Now we are going to substitute this equation that we found last time, equation 3, into equation that we called equation 1. So this equation here. So this seems complicated, but it's not complicated. We simply need to substitute that expression here for chi nu, and chi alpha, basically, because we have found a way to express chi nu in terms of h mu and h. So let's do it. It's quite straightforward. So we have d sigma h mu minus d mu d rho h rho nu minus d nu d rho h rho mu plus d mu d nu h plus era mu nu d alpha d beta h alpha beta minus d sigma h plus d mu d alpha h alpha nu minus 1/2 era alpha nu h plus d nu d alpha h alpha mu minus 1/2 era alpha mu h minus d alpha d beta h beta alpha minus 1/2 era beta alpha h era mu nu plus t mu nu equal to 0. Now at this point there are terms that will cancel. So in particular this one will cancel this one here. So for example, here you can lower this alpha and you can raise this alpha, and you can see that this one will cancel this one. Then this one here will cancel this one down here. So you can see that this one is exactly this one with a minus sign if you lower this alpha and if you raise this alpha. Then what else do we have? This one here will cancel this one here, multiplied of course by era mu nu. So I'm just highlighting it like this. We can rewrite everything in the following fashion: d sigma h mu nu plus d mu d nu h minus d sigma h times era mu nu minus 1/2 d mu d nu h plus minus 1/2 d nu d mu h plus 1/2 d alpha h times era mu nu plus t mu nu equal to 0. Now actually there is also another kind of simplification that you can make at this point. So this one together with this one and this one. So you can see that this one and this one will add together, but together they will also cancel this one, because we have minus 1/2, which will give us minus 1, and therefore they will cancel this one. So the equation can be simplified, and what we get is the following. So this d sigma can be written as the D'Alembert operator, h mu nu. Then we also have another D'Alembert operator here and here. So they can be, so this one can be put together with this one, and that will give us a minus 1/2 h era mu nu. Then we have plus t mu nu equal to 0. Or if you want, we can rewrite it like this, minus this D'Alembert operator equal to t mu nu, like this. So this is an equation that we derive, and actually here we can still try to understand the physics a little bit more, because, well, this is just a wave equation. So this explains for the propagation of gravitational waves. So here we have the source of the gravitational waves, and you can see that indeed this is a wave equation, because we have the D'Alembert operator. Of course, there is this minus sign, but also remember that we have a signature, a particular signature for the Minkowski metric. So at the end of the day, this operator here is just 1 over c squared d squared dt squared minus the Laplacian, right? But never mind. So I'm also going to rewrite it with upper indices for the sake of convenience. So I'm going to write it as minus D'Alembert h mu nu with upper indices minus 1/2 h era mu nu equal to t mu nu with upper indices. And I'm going to call this equation 4. But we will move on from here next time.